Hello everyone. Today in this lab we're going to be doing the second week of the concrete labs. We'll be mixing and curing concrete, doing a slump test and an air content test. The first thing we'll go over is mixing the concrete. The second step is doing your slump test. Third will be air content, and fourth will be placing the concrete into the molds and putting them into the room to cure. So for preparing the concrete cylinders, the mixing portion is ASTM C192 standard practice for making and curing concrete test specimens in the laboratory. This is done to verify that the concrete meets compressive strength and slump requirements prior to it being placed in the field. You don't want concrete brought out to the field that you've not tested and it ends up not working, not being strong enough. You're going to have failures in beams, columns, slabs. You're going to have lots of cracking. You could have other workability issues if you don't get your slump right and you haven't tested it prior. So it's always good to follow this procedure and make sure that your concrete mixture works in the lab prior to actually putting it into use in the field. The equipment that we're going to be using is a mixing drum, a wheelbarrow to collect the concrete, a rubber mallet, and 4 5-gallon buckets. Each of those buckets is going to have our granite, sand, cement, and water all separated so that we can add them in the way that the specification has. And we have the weights for each of these weighed out. And this is just the different water to cement ratios from 0.5 to 0.7. We're only doing 0.5 to 0.6. I just have these in here to show you like what's changing and how differently they are. In the real world, you probably wouldn't use something this high water to cement ratio because that would make your mix super watered down, and that's not going to be very strong. We do know that the optimum water to cement ratio is somewhere between 0.5 and 0.6, so that's why we're testing these 5, and y'all will be able to figure out which ones pass, which water to cement ratio you would want to use for the specified project in the assignment. So you can see we keep the granite, sand, cement, all the same weights for everything. The only thing that we're changing is the water. We're going to increase that at each step up on the water to cement ratio. And we have total weights about 100 pounds. So that's going to make a little bit less than 1 cubic foot of concrete. I think 1 cubic foot of concrete is somewhere between 140 to 150 pounds. But we don't need a whole lot for our lab for each group, so we're not going to make a whole lot of concrete. The procedure for this, what you're going to do is you weigh out each part. All the weights are provided in that last table. You're going to separate them into those drums, and then before you actually start the mixing drum, you're going to add half of the water and all of the coarse aggregate, all of our granite, and then you're going to start the mixing drum. And then once the coarse aggregate is damp, you're going to add the fine aggregate or sand. Then you're going to add the cement, followed by the remaining water. You're going to mix for 3 minutes, follow a 3-minute rest period to let the chemical reaction happen between the cement and the water, and then you're going to complete it with a 2-minute mixing period. And then you're going to dump the contents into a wheelbarrow. And so we have a video right here of me performing the mixing just so you can see how it actually works in the lab.
All right guys, we're going to be making concrete right now. We're going to start the mixing process. So we've got our concrete mixer here underneath Harbor at Auburn, and we've got all of our materials here that we're going to dump into it. So you can see we've got our coarse aggregate, which is granite. You can do limestone or any other coarse aggregate if you want. We've also got our fine aggregate, which is just sand. We have cement, which I'm not going to touch. And then we have water here. We've weighed them out, and we're doing the 0.5 water to cement ratio. The other groups will be doing the other water to cement ratios for this lab, but we've decided to film using the 0.5. So we've weighed these out accordingly based on that sheet that you'll have on Canvas. So the first step for mixing concrete is we need to put our aggregates in here and all our materials. Prior to this video starting, we actually buttered it with water because moisture mixture likes to stick to this metal, and so we just dumped a little bit of water in there, and then we dumped it out. So most of the water's out. You can see we poured it out on the floor. But we do that because we don't want to lose our water that we've weighed for the sample. It'll stick to the inside, and that's not good. So the first step is adding half of our coarse aggregate, is adding all of our coarse aggregate. Okay, and then we're gonna add half of our water. I'm not putting my mask on yet because I'm not tossing the cement in. Right before I do that, I'm gonna put this on because I don't want the silica dust in my lungs. All right, so we're gonna do half of the water, roughly. All right. And then we're gonna turn the concrete mixer on. It's gonna get a little loud, maybe. Hopefully I can yell loud enough for you to hear me. And we're just gonna turn it on until the coarse aggregate gets damp. And then we'll throw in the cement, we'll throw in the sand, then the cement, and then the rest of the water. Step of the procedure is letting it sit for 3 minutes. That lets the chemical reaction between the water and the cement happen and gives it time to start to activate. So we'll be back in 3 minutes, and then we'll mix for 2 right after that. All right, it's been sitting for 3 minutes now. We're gonna go ahead and turn it back on for 2 minutes. We'll be back when the 2 minutes is up, and we'll put it into a wheelbarrow. Is up now, and we're going to get it out and put it into the wheelbarrow. So we buttered the wheelbarrow a little bit. You can see it's a little shiny with water. And so the best way to actually get the concrete out is by turning this on and dumping it, and you hit it along the sides to get all of it out into the wheelbarrow. So that was pretty hard, doing it on my own, so we turned it off and had Surrey help me. Now we need to make sure the mix is nice and homogenized. So, I'm just going to mix it up a bunch. Now this mix is a lot harder to use because it's the lowest water to cement ratio we're doing. So we still have some stuck in there, not a whole lot. So this hopefully should do as well with our weights for all of our other tests. So we'll meet you over there and do slump test.
All right, so I hope that made sense. It's kind of what I said. I'm just going through the procedures and stuff like that. So the next thing you want to test is your slump. ASTM C143, standard test method for slump of hydraulic cement concrete. The slump test will allow the user to gauge the workability of the concrete mix. Slump shouldn't be used to determine the quality of the concrete mix. You don't want to say this is a good mix based on the slump because you haven't tested the compressive strength of it or the air content. The air content's important for other properties that we'll discuss later, but you don't want to solely use the slump as a test for quality. It's a very common test, but you need to do other tests additionally with it. So the equipment is you're going to have a slump cone and a base. The cone kind of looks like this. And then it has a flat base that it sits on. You're going to have a measuring stick or ruler, a scoop, tamping rod, and a strike-off bar. And so when you do slump, your concrete's going to be in this cone shape outlined right here. It's actually going to look like this 0-1. And you'll pull the cone up, and the concrete will slump down. If you add a lot of water, it will look like this collapsed. That's not good. If you didn't mix it properly or it was not homogenized, it could shear because could be more water on one side or the mix just isn't right. If you have like barely any water or very little amounts of it, it can be a 0 where it just doesn't move. And then if you have a good amount of water, it's going to slump down a little bit like this true slump. You do want slump. If you don't have anything like 0, it's probably going to be really hard to pour into whatever you're doing, whether it's a slab, a beam, a column, or anything else, because you can't get it around the rebar, and you really need to. So down here you can see that there's maximum and minimum slumps. Reinforced foundation wall, a maximum of 3, minimum of 1. So all of them have a minimum of 1. That 1 and 3, those are in inches. So it's measured in inches from the top down. So this is 0. This would probably be like 3 inches. This would probably be like 10. And this you couldn't read it because it's not homogenized right. So so that's, you want a slump that looks like this, nice even like sinking of the concrete. Procedure, you're going to dampen the mold and the base, or the cone and the base, with water just so it doesn't stick to it. And then you're going to place the concrete in 3 lifts, rodding it 25 times each after each lift. The final lift is going to have an excess of concrete remaining after tamping. That way you can smooth off the top and it's not sunken in already prior to you lifting the cone. And then you're going to screed off the remaining concrete with a rolling motion. Very similar to the unit weight aggregate where we rolled a rod across the top of it, that way to get a smooth top to it that's not like messed up in any way. You'll see me do it in person, or you'll see me do it in the video following this slide. And then in a single motion, you'll raise the cone mold vertically, immediately recording the amount of slump in inches. So we'll go ahead and watch this video.
All right, so we got the slump test. We're gonna slump cone here in our base plate for the slump. And we've got a little catch basin so that we can reuse this concrete. The first step is buttering it like everything else we've done. We don't want moisture to stick and for us to lose moisture that's in the concrete. So you can just wet it real quick. Like that. And then we'll shake it out. And like that. So now what we're going to do, load our slump cone into here. And we lock it into place. And then we'll go 3 lifts. So our first lift, we'll toss it in here. about a third of the way full. And now I'm going to use my rod right here. And you're just going to run it 25 times around inside it. All right, that's 25. Second. Again, and you want to go about an inch into the next lift. So it was about right here, so that's how far we want to go. All right, 25, and then the last one we're going to fill over the top. Times again, not all the way down, right there. All right, now what we're going to do is we're going to clean off the base, and we're going to lift this slump cone up and get our reading. So we'll move these out of the way. That's out of the way. All right, and then I'm just going to lift straight up. And then our slump. Our slump is this reading from the top of the concrete, about right there, to the bottom of this. So we got about 1.5 inches. We're going to go measure with a ruler real quick. We did not bring one outside. It's about 1.5 inches though, and the slump will increase. So you'll get a slump of 2, 3, or 4 as the water increases, because it's going to be more workable. It's not going to hold as much. So because ours has so little water in it compared to the others, ours is going to have the lowest slump. So now what we can do is take this and reuse it, because we didn't introduce any extra water into the sample. So we're done with our slump test now, and we will do our next test right after this.
All right, the next test is the air content test. ASTM C231 standard test method for air content of freshly mixed concrete by the pressure method. It allows us to determine the amount of air trapped in the concrete. The more air voids you have in the concrete, the more workable it is, but the side effect of that is the more air voids, the lower compressive strength you're going to get, because there's so many voids. There's not concrete, there's not cement or fine and coarse aggregate taking up that space. So it's not as strong as it could be if there's less air. But entrained air, or like air inside the concrete, is good to prevent resistance to freeze thaw. So sometimes they'll intentionally entrain air by putting they'll like pump air into the concrete right after it's poured. That way there's like little micro bubbles that have space for water to get into, moisture to get into and freeze, but not expand and crack the concrete. That's a real big issue with concrete pavements, is cracking of them. So we're going to test for air voids and just see where we're at, and we'll report that number on our assignment sheet on our report. So the equipment, it looks exactly like this on the right side. It's just an air meter, the cover and the measuring bowl. which is what's on the right, then a tamping rod, rubber mallet, a scoop, strike-off bar, rubber bulb syringe, and a bowl of water. The procedure, you're going to dampen the inside of the measuring bowl, same as everything else, so you don't want the concrete to stick. Then you'll place 3 equal lifts into the bowl, routing 25 times evenly over the cross section of the bowl. You'll tap the 4 sides of the bowl 3 to 4 times with a rubber mallet after each lift to let the concrete settle in. And then we're going to slide the strike-off bar across the top of the bowl in a sawing motion to smooth the top of the concrete. Kind of similar to mortar with using the rubber hamper to, I guess, in a sawing motion, smooth off the top of the mortar cube. We're going to do the same thing for the concrete. And then we're going to clean the rim of the bowl so that the good seal is obtained and attach the cover to it. Close the main air bleeder valve between the cover and the bowl. That way when you pump it, no air comes out of the bowl. That way you can get a good pressure on the system. And then you're going to open both side petcocks on the cover, the little things right here. You're going to open these up, and you're going to feed water into one until water comes out. That way all your concrete's filling up this whole bowl, and you're going to put water in the top. That way it takes all the space of the air. The bleeder valve is this thing up here, and then you're going to be pumping this thing until it goes up to a reading of 0, and you're going to tap the side of the measure and with a mallet, and you're going to release the main air valve, and any air that's stuck in the concrete, because this is put to 0, when you hit it with a hammer, all the air kind of shifts and moves, and when it's under pressure, it's going to move up to the top, and it'll actually change this from 0 to like 2, 3, or 4% air. So that's the remaining of the procedure. I just wanted to kind of read it and kind of show you what's happening. So you'll read the percent of air content, and then you can take the stuff off, and you can take the cover off and get rid of the concrete because you already introduced a lot of water. So you wouldn't reuse this concrete in the making of the cylinders or a slump test. This is kind of the last test that you want to do. So we got a video so that you can see how it works.
All right, we're doing the air content test now after doing our cylinders and after doing our slump test. So again, we want to make sure that we got our bowl buttered. So I'm just gonna add a little bit in here. All right, so this one we're gonna fill in 3 lifts. All right, rod 25 times. All right, and then tap 3 or 4 times on each side. All right. to screed off the top. Okay, now what we're gonna do is I'm gonna grab paper towels. Video's still rolling. Paper towels. And I wanna clean off the rim because we have to have a good seat from the top. This step is super important because if you don't have a good seal, your test isn't going to work. All right, so I think I've got it. A lot of times contractors use, I think, like wet rags. But we've just got paper towels. So now, this is our top. And we've got, this is where we're pulling our vacuum. So we're trying to figure out how much air is in here. So we're going to flood it with water. And then we're going to shake the measure with a hammer, and any air that's in the concrete itself is going to seep up to the top, and we'll be able to read it from this dial. So we've got the inlets for the water and the air right there. So we'll go ahead and strap it on.
After completing the strike off and cleaning of the lip of the air pot, want to ensure that the seal on the top of the pot is moist. Give it a slight twist to ensure that you don't have any aggregate stuck between the lip and the seal. You're going to lock your clamps down 2 by 2. With both petcocks open, bleeder valve closed, main air valve closed. You're going to insert water through one petcock. While you're inserting the water, you're going to jar the meter to displace any trapped air. Jarring can be left open to some interpretation. This can also be considered jarring. All you want to do is loosen the constraints of the entrapped air and get it out. After you've got standing water in both petcocks, you want to pump up the air meter to its IP. The IP on this pot is 2. Tap the back of the gauge to stabilize the needle. With the needle stabilized at 2, we're going to ensure that we still have standing water in both petcocks. We'll close both petcocks. Now at this point, we'll depress the main air valve to release the air from the air chamber into the pot. When we depress it, we're going to strike the sides of the air meter. That's a plural word, sides. You need to strike the pot a minimum of 2 times. After striking the pot, tap the back of the gauge till the needle stabilizes. Continue to hold the main air valve open till that needle stabilizes. Once the needle's stabilized, you can release the valve and get your reading to the nearest 1/10. Anything over 8%, you'll get to the nearest 0.5%. So it'll be 8, 8.5, 9, 9.5.
All right, so I hope that made sense. Yeah, we had some issues with our pot. We were missing the bleeder valve on the top, and then this pump had an O-ring that was missing. So I guess whoever used it last had messed it up and didn't want to mention that we'd have to buy a new one. So we will be getting a new one for the next semester. So the last thing, and you actually can do this typically before air content test, that way you don't reuse any of that concrete you used in that last test. This ASTM is C192, and it's just part of the mold and curing. It's the placing in the mold and curing part of ASTM C192. That was also in the mixing ASTM. The equipment, you can use 6x12 or 4x8 plastic molds and caps. You kind of choose. We've got the weights selected for the 4x8 inch plastic molds because we don't want to use a lot of material. And it's good to switch sizes every few semesters just to get different data. And then you also need a rubber mallet, tamping rod, and strike-off bar. The procedure, for the 6x12 molds, you'll fill in 3 lifts. For the 4x8 mold, you'll fill in 2 lifts, and you will rod it 25 times after each lift and tap the sides of the cylinder 3 to 4 times each, very similar to the air content test. Then you'll strike off the top cap and label it accordingly, and then you'll place the molds in the curing room for 7 days. So we'll get our 7-day compression strength requirement, or we'll get our 7-day compression strength test and compare it to that requirement in the assignment. So we've got a video on this, shouldn't be too long.
All right, so before we do our air content test, because that test adds water to the concrete, we don't want to reuse that. So we're gonna go ahead and fill up our cylinders with concrete. So I'll show you that process on one of them, and then we'll do it for the second one after that off camera. So first thing you're gonna wanna do, I'm a broken record, you wanna butter it. Now you don't want to add water to the mix, you just want to make sure that it's not going to stick to it. So that's good. And then we'll fill it in 2 lifts. Pretty good right there. Alright, gonna get our rod, and we'll do 25 rods. The next step is you want to tap the sides. Lightly, that way the mix settles. So our second lift. Because it's going to overflow, I want to use a catch bit. All right, 25 rods. top isn't that satisfactory because we want it to be a nice smooth sample. So we might do a little editing of this sample here. I think we're going to cut the video. We're trying to make it a smooth top because we can't do any compression testing. So we'll do this off camera. So that's how you do it. After you're done, you will put your cap right on top and we'll go throw it in the curing room for 7 days.
So the reason why we decided to fix it after the video is just because we're trying to use this sample as a sample next week when we actually test the compressive strength. If it was all choppy like that on the top, that'd be good to report in the assignment and say that it didn't level out and it probably wasn't workable enough. The water content was probably too low. But we wanted to get a nice smooth top, that way we could actually test it right for the next video. So next lab, we'll be doing compression strength testing of our 14-day cured mortar cubes and our 7-day cured concrete cylinders. So that is all. Thank you.